Hello. I'll do today's contest like midday today in a few hours. I haven't looked at it yet. I'll put that in a message. And then if you have any questions about specific problems, you can ask about that. Hello, Uncle. Yes. Pin message. Alright. Okay. Well, here we are. It's late and it's early at the same time. It's it's late, but it's normally late, so it's like not that late, you know. It's whatever. Okay, let's get started. So this got 0 solves in contest, so we're not gonna touch it. G seems reasonable. We do that. Where were we in code yesterday? We have 998 mod enabled. We have L is long. It can be 0. Sure. Huh. Okay. Interesting. Very first days in competitive programming. Thought that the merge sort is too slow, so we restricted the maximum depth of recursion and modified the merge sort to do the following. If h is less than or equal to 1, then the expected number of inversions after calling B is an empty array. I just learned to write merge sort. So he restricted the maximum depth of recursion. Okay. So we're thinking about inversions. After calling merge sort A, 1, and K. So 1, 3, that was going to be the middle. So for odd, we have more elements on the left. It kind of matters, I suppose. Okay, so any inversion will be kept. Any inversion will be kept. Right. So any inversion in the original array will be kept. And we need to think about how merging works. So merging two unsorted arrays will consider the biggest element. We'll take every element from the back of it. Considering the position of the biggest element, we'll take every element from the back of it and then move it there. so that we have these blocks. It does seem like you're supposed to be asleep. Why are you not? So that we have these blocks. So we have these blocks. These blocks are going to be sorted, but then anything inside the blocks could be anything. So we have a block for the maximum element. How many permutations do we have where we have this many blocks? Right. So if we're considering the blocks of the suffix maximums, suffix or prefix? Where you're a prefix maximum. Yeah, where you're a prefix maximum. So we highlight the prefix maximums. And we place you together, then we're going to merge the prefix maximums correctly. And the rest will not be merged correctly. So we need to find the expected number of inversions with the non-correct stuff. Right, so can we do it all at once? I don't know about ever. Improvement is hard. Slow process. I mean, each problem gap is what, like 300, 400 points? It's a lot of points. The fact that n is not a power of 2 is kind of a shame. Two, 1, 3. Yeah. And then you're going to be merged correctly. Yeah, so we just need to figure out these blocks. Yeah, like 10ish. I sleep a lot. Okay, so we fixed some element out. Fix some element x. At position P. And everything in its neighborhood is strictly less than x. Fix some element x at position P. And every element in its neighborhood is strictly less than x. So I mean, then these guys could be literally anything. Conditioning on the fact that there's no element less than you over here. And this will form an inversion with everything in its group. Everything in its group can form an inversion with itself. And it's 10 to the 5th. That's a shame. Everything in its group can form an inversion with itself. So let's fix like 5, for example, right? How many inversions are going to happen in 5's group? So I have a certain number of elements less than 5. I have 4 elements less than 5. Why don't we just count the inversions that 5 contributes? Well, that's kind of tricky though. So I mean, how'd we do that? So 5 contributes what? No, that doesn't seem like it worked. 5 could be in some arbitrary group, and then it's kind of complicated. Let's not. Let's say 5's group instead. We're going to count the inversions for each group. We're going to count the inversions for each group within the group, with the group and the leader, and to the left of the group. And that's good enough. does this work? Hello. Stuff. Every group will be correctly sorted. Right. So there are two types of initial arrays. We don't really care about. Yeah. So what's the expected number of elements in 5's group? And we need the probability that 5 even ends up in its own group. And we're counting arrays. The number of arrays such that 5 is inside its own group. How does that work? Buying shoes, sure. Go ahead. Go ahead, I suppose. So we have 8 groups. We have one of size 2. And that thing of size 2 can do whatever the hell it wants. And we're only interested in the arrays where 5 ends up in its own group. So we place 5 in its own array. How many such arrays are there where 5 ends up in its own group? We're okay with n cubed for now. I just want to figure this out. What are the number of arrays where 5 ends up in its own group? So we place 5 down like here. This is complicated. It's getting very complicated. Can we do this? Can we do this whole group approach? Just consider the elements less than or equal to 5, right? There are 5 elements less than or equal to 5. I'm going to place them down in places. Ah, the non-uniformity is really getting to me. If 5 elements less than or equal to 5, we're going to place them down in places. We have only one array, and the number of elements less than or equal to 5. Damn. This doesn't seem possible. Let's try something else. What's the expected number of inversions that 5 contributes, right? If it's in a group of its own, then it contributes 1 inversion with everything in its group. If it's in a group with something else, okay, we don't need to fix 5. Just consider the final structure of the permutation, right? For some particular group, for some particular group leader, it will form an inversion with everything in its group. And then everything in its group will form an inversion with everything in itself. And then regardless of the group structure outside, everything inside the group will form half an inversion with everything outside the group. Just because these are all numbers like this, and they can be shuffled however the hell they want. Yeah. Wait. So what? Are we counting the expected number of groups? So suppose there are k groups. Then there are n minus k choose 2 inversions right off the bat. Suppose there are k groups. Then there are n minus k choose 2 inversions from that. The group leaders don't form inversions. Wait, no, it's not n minus k choose 2. Wait, what is it? Wait, what are you? No, it's not exactly that. It's like for a group like this, is a function of k? Now if we have n groups, we have 0. We have another number of groups, depends on where the groups are, right? Like if we have a group like this, We have 7 half inversions. Wait, we're not we're being careful here. We're saying if there's a group leader here, how about this? Considering that there's a group leader at position X, everything to the left is less than or equal to X. So you can do whatever the hell you want. Everything in here is a guaranteed inversion. Everything in here is a guaranteed non-inversion. Everything else is half. Well, no. That's not true. Everything across is half. Everything outside can do whatever the hell it wants. can't just do the number of groups? Because we get a 2, 1. And that's dumb. If we have like a group of length k attached to what? Attached to what? All right, let's consider it this way. Let's consider it this way, right? Let's consider the number of permutations such that this forms a group. It isn't square, but it's fine. So if you're going to be here, fixing that this is the biggest. So I've got like a potential group of length k. If this is the biggest element, I mean, but then what? For this formulation, we need the number of elements to the left, which is the set of elements strictly less than u. And we can go back to fixing 5 to be here. All right, let's fix 5 to be here. If we fix 5 to be here, and then say its group size is going to be this. So we need to choose some number from the set of elements less than 5. And cubed, but that's okay. Choose some number from the set of elements less than 5. Right. Then we just need the expected number of elements less than 5 that are bigger. We have this, like, what is it, negative binomial? What is this? No, what is it called? It's not this, right? This is not a hypergeometric, right? Probability theory and statistics describes the probability of k successes and n draws without replacement for a finite population size n that contains, yeah. Except the expected value is still NP, right? Where are you? Give me the frickin'... Yeah, nk over n. Well, no, but we're stopping at a failure, right? Yeah, damn, we're stopping at a failure. How does that work? So we have these, like, other things. Right. How does this work? This isn't what we need. And by linearity, like, we're gonna assume that we can assume that. So we just need to know, given k1s and x1s and y0s, given that we pull until we get a 0, what's the expected number of ones? Except we don't have replacement. We don't have replacement. K1s and X0s. Well, we can apply linearity here. Yeah, we can apply linearity here since we're just looking for the expectation. So if we fix that you're going to be here, we fix that you're going to be here. Then the expected number of zeros we get is given by this probability distribution. Or rather, contribution to sum, right? So replacing the 5 on the x plus 1. Placing the 5 on the x. And we have a certain number of elements less than 5. A certain number of elements greater, right? I mean, the 5 has equal probability of being anywhere here. So this actually becomes n squared, right? sure. Let's do this. So Cn, how does this work? So we have n mod k ceilings and n minus n mod k floors. So it's still n squared, but we'll see if it works. Because at this point, n squared is better than nothing, right? So vector PLV. We need mod op. So into n to k to mod. Stop it. Gen factorial n v dot push back n over k n minus n mod k v dot push back make sure this actually makes sense. What? Stop. Oh my god. Can you not? Can you not? Can you, bro, can you terminate? Yes, Jesus. Okay, thank you. 1821. Wait, that's not right. Minus k. Yeah, okay. 2, 8. What? K. Yes. Okay. 2, 3, 3, 1. 1, 1, 2, 1. Yes. Okay. Cool. All right. So what we need to do then is ants is equal to 0. 4 li is 1 is equal to n plus plus. LCV vector PL RSV if C is greater than 0. For auto XCR, if X is equal to L minus C. now. Um, 2, 3, 3, 1, 2, 2, 3, 1. Yes. Okay. Good. Now, allow CB is I minus 1, CS, CB is N minus I, right? Yeah. Okay, so, I will be right back. Stop. Okay, we'll write the n cube first, I guess. Is Kevin my teammate? No, he's funny. That's what he is. He's funny. F is fact CS times fact CB mod mod. 4 k is 1, k is less than equal to L, k plus plus minus CS. Okay, so RB. If K is not equal to L, minus RB, if RB, continue. Well, toad is equal to F times NCK CS plus RB CS. Okay, so T is equal to 0. Okay, so let's see what L. Am I doing this with someone? No. I am forever alone. Yeah. For auto XCR. Oh, we don't actually need this then, right? Do we need this? I don't think we need this. Zero. TT equals TT plus P times NCK ES plus EB mod. T is equal to T plus TT times F mod. times C. No, wait, this is ES. ES is equal to ES plus TT times C. L is equal to P minus 1, R is equal to K minus P. T is equal to T plus R times L plus ES mod mod. R times L plus ES mod mod. All right. And this is 2. Why are you 2? That's wrong. Okay. So for I is 0, I is less than or equal to n, I plus plus. R is V. Well, T is 0. CS is I minus 1, CB is n minus I. Well, F is 2. I is 1, F is 2. Yeah, sure. Oh, wait. R times NCK that shouldn't fix it, but oh, that does fix it. Does that actually fix it? No. Okay, worth a shot. What? 3. Okay, sure. Right. So why is this thing? So L answer 0. For I is 1 up to n, for each segment length in V, C is greater than 0. Vector PLR is V. For auto XCR, X is L minus minus C. Well, T is 0. Well, CS is I minus 1, CB is n minus I. F is fact CS times fact CB mod mod. For K is 1 up to L for each segment length. RB is CB. If K is not equal to L, we need to place a big here. Then if RB is less than 0, continue. Well, ES is 0. For auto XCR, TT is 0, ES is CS. So for P is 1 up to X, right, we're going to do minus minus ES. For P is 1 up to X, all right, so we're going to use a small. If ES is less than 0, break. If P is not equal to X, we're going to use a big. If EB is less than 0, continue. Then we have this probability. We have this many elements. Then ES is ES plus TT times C mod mod. Oh. This is 5. Damn. Shouldn't change this here, right? Yeah. Why is that 5? PR, I, CS, CB, EV. CB is 1. EV is 1. Oh, wait, right. Okay. Comes from M2. Cool. Damn. So we're getting this right, but not the other one. Where's my CS? If CS is less than 0, continue. T is T times F, mod. T is T times C, mod. What in the world? Okay, so if I is 1, then the expected number of inversions with I is going to be nothing, right? If I is 2, and if we're placing U here, if I is 2, if I is 2, L is 2, we're placing U down here. I is 2, L is 2. Okay, let's okay, so we're overcounting. Overcounting by a lot. Why are we overcounting by a lot? And we haven't even considered. Wait, I'm an idiot. Oh, okay. Okay, sure. Okay, so we have all the factors. Okay, sure. Sure. Alright, so... comp R... Let's do some stuff. So, I mean, you're obviously going to be that. Yeah, over 2. Okay, sure. Do 110. Should be 0, right? Yeah. Okay, sure. We'll save this code. Why not? So this is n cubed, obviously. So it's not really gonna, we don't need this code anymore. We're not gonna, this is stupid. We're not gonna do this. Okay, so how do we speed this up? Right, because obviously why? Yeah, you're gonna take a while. Okay, whatever. Sure. So we're iterating I, and we're iterating the length, right? I mean, we have 2 n cubed parts. We're iterating I, then we're iterating the length. Can we somehow like wave our hands and just say no? So I mean, this loop we can probably optimize away. That we can get rid of, that's fine. That's not the issue. Fundamentally, the issue is that this is n squared, right? So it's n cubed. For auto XCR, well, TT is 0, LES is CS. LP is 1 up to x. Minus ES. If ES is less than 0, break. EB is RB. If P is not equal to X, minus EB. Should run like decently quickly, right? Yeah. So I mean, for big K, it's fine. For small K, we have a problem. Why are you taking so long? Like if n is 1, we have a problem. Sure. I mean, so you get a number, that's fine. Seem to indicate a mod. So I mean, there's like a bunch of independent pieces. The hardest part being the stuff with the others. It's a bunch of independent pieces. How do we handle a bunch of independent pieces? SI minus 1 CBS and minus I. Well, F is fact CS times fact CB mod mod. And somehow we turn this into an answer, right? So like the fundamental problem is the in-choose Ks. Actually, this can be hockey sticked, I guess. Right? Yeah, this can be hockey sticked. Okay, that's fine. Okay, this can be hockey sticked. This can be optimized away. The problem is this loop. How do we handle that loop? And we might even be able to get like a weighted average of this, right? How do we optimize away the main loop? K is 1 up to L. RB is CB. If K is not equal to L, minus RB. Right. So we can case on taking you away or not. Problem is the weights, right? The problem is the weights, that we have some factor times some binomial. We can't exactly get rid of both. EB is EV plus TT times C mod mod. For P is 1. For P is 1, P is less than or equal to K, P plus plus. Well, L is P plus 1, R is K minus P. L times NCK, CS plus RB, RB. Mod times mu, 2 mod mod. God, man, it had to be math. Math. NKQ. How do we optimize this to, what, linear? Has to be linear-ish, right? Maybe n log n, n log mod, something. For K is 1 up to L, K plus plus. RB is CB. If K is not equal to L, minus RB. If RB is less than 0, continue. So I mean, that part can be hockey stick, but it doesn't really help us. Because a hockey stick times some coefficients, which we can't just like get rid of. We do better, right? I mean, with expected value, there's always a chance of a better formulation. So, can we do better? Do we need to fix the element? We kind of do, don't we? Like, we almost certainly do. So we can do this right now, right? TG is TG plus. No, wait, it's weighted by, oh god. Wait, it's weighted by the element. Wait, so that doesn't even work. It's weighted by the element. Sorry. PREB. That doesn't particularly help, right? Does it? 16/5. I mean, it's just like a lot of possible values. Like 25/7. What the hell is that? Okay, that doesn't even work. I need to do better, right? So, supposing I'm sneezing like my dad. Fills up the whole room with noise. I can hear the wind outside. we need different formulations. I mean, like, whatever the hell is going on in this code is not going to extend to something that's linear, probably. We just need to be smarter. Take well, you can consider element by element. Two elements will form half an inversion if, say, you end up in the same group together. So if you end up in the same group together, then you'll form half an inversion. Every group element will form half an inversion with every other group element. So we can do that way. Every group element will form half an inversion with every other group element. Every group leader will form half an inversion with every group element to the right of it. Okay. Every element forms half an inversion with every non-group leader to the right of it. Right? Every element will form half an inversion with every non-group leader to the right of it. Every non-group leader to the right of it. Because if you're, yeah. Every group leader forms no inversions with every group leader to the left of it. Every element will form half an inversion with every non-group leader to the right of it. So, I mean, this proves that this idea has merit. It means that we're not completely wrong. We just need to get it to be a lot faster. every group leader but I mean, if we consider 5, any element less than 5 that ends up in a group every element in a group forms half an inversion with every other element in that group. So, I mean, given the group structure, right? How do we even do that? We can get the probability of having a particular group structure. Then we could do this. Every group element forms half an inversion with everything else in its group. We can do that easily. I mean, this entire part is independent of everything. Yeah. Every group element. The only parameter here is EV. So yeah, we have 3 types of inversions. We have half inversions between group elements and themselves. We have half inversions between group elements and everything on the left. We have full inversions with group elements and their leader. How else do we represent that? So every group element forms a half inversion with everything to its left. With everything to its left. Everything to its left. And every non-group leader to its right. We'll just say everything to its left, right? every group leader forms an inversion with every non-group leader to its right, right? If you think about it in terms of inversions in the what? The original array is 2. Because every inversion in the original array is kept. Relative order within the original arrays are kept. So, I mean, how many inversions do we get from a merge? So we're going to take the last group. Last group. So, I mean, all of the inversion counting comes from here. Like, this is all the inversion counting. So if we fix that we want like a 1 here, right? How does this work? If we fix that we want a 1 here, if we fix that we want a 1 here, fix that we want a 1 here. How do we fix that we want a 1 here? I mean, 1's useless. how do we do that without fixing the number of elements? If we put a 5, just somewhere here. This is so weird to count. In case anyone actually wants it. What in the world? Stop. In case anyone actually wants it, we'll do this. It's been a while since I've touched that, huh? Staring at these is not gonna help, really. Ugh. probability that this works out. So, if the groups can be what? If the groups can be merged. No. That's the behavior of merged. Let's go with this less than or equal idea somewhere. If it's less than or equal to 5, what does that do for us? Place the elements less than or equal to 5 down somewhere. Maybe just say 5 is going to be one of them. bunch of number of elements from these. The problem is we're conditioning on the fact that 5 forms a group. If we condition on the fact that 5 forms a group, then it gets complicated. I mean, maybe we don't need to fix the element. We could somehow not fix the element. actually, if we fix a pair, I mean, the number of group inversions is completely independent. That we can do in like linear, I think. Yeah, number of group inversions we can do in linear. Okay, yeah, so this part and this part we can do in linear. This part is the hard part. This part we can probably do in linear too. Do it with FFT, huh? Yeah, okay, that we can do in linear. Okay, so the only hard part then is figuring out group inversions crossed with stuff to the left of it. Yeah. Like, given a particular element that's in a group, you need to count the thing, you need to get the expected number of things to the left of it. Which is the expected number of things strictly less than the group leader. Expected number of things strictly less than the group leader. So, I mean, again, if we could get the... What? What are you as a function of this? ILX. CS is 5. This is dumb. What are we doing? Let's look this up. Negative hypergeometric distribution. Do you have a nice mean? Huh, you do. You're like capped. You're capped by K. What does the capness mean? Like if you weren't capped, then this would be fine, right? The fact that you are capped is a problem. Also, you're still like weighted. It's still... No, it's still weighted by the inches K. I mean, we have big N choose K. It's still weighted, man. It's still weighted. We're placing you down. And what? What does that mean? Okay, this page is useless. Let's get rid of it. It's still weighted, man. It is still weighted. What do we do about the fact that it's still weighted? What's like... T plus R times L mod times min 2 mod. Because all of these are the easy parts. This code still works, right? Let me just comment all these out. Let's see what the hell happens. What? I'm sorry, what? I have an idea. Oh, wait. No, wait. Wait, why does that make such a little difference? Wait, that's kind of 25. Is that actually it? What in the world? I'm sorry, what? Okay, well that makes life easier. Sure. Oh yeah, right. Yeah, because all of these are constrained to a single array. Okay. So all we're concerned about is the cross array computations, right? So these are the cross array computations. That's like the entire problem. Okay. I see. So at end, ants plus equals. Sure, we can do that. Can we just like... Alright, wait. So we're looking for cross array computations now, because the rest is easy. Can we just do array? Like, just do that? scared of individual elements, right? No, not yet. I haven't done that yet. I'm still on this problem. So what if we just like, what if we just completely screw the semblance of elements, right? And we just what? Can we do this? Wait. Wait up. Wait, I kind of feel like we can. Wait up. Oh my god, I have a crazy idea. So let's like get rid of all this. Get rid of all of this. So we're just gonna straight up screw all of this. Just comment it out for now. Well, actually, you're saved, right? So we'll just screw it. For this, I want to save actually. For auto LCV. Crazy idea. This would work, right? So we need a big element here, a big element here. Then a big element here. Then all of you less than or equal to this. All of you strictly less than this. All of you strictly less than this. The rest of these don't matter. That's the setup, right? Big element here, big element here. Order of these two don't matter. Then all of you are strictly less than this. big element here, big element here. This max is on this side. Yeah. Yeah, we can do this. Okay. Okay. For auto XCR for L T is 1, T is less than or equal to L P plus plus. Q is less than or equal to X. Well, F is 1. D is equal to P plus Q plus 2. If P is not equal to L, minus D. If Q is not equal to X, F is equal to F times mim D mod minus D. For LOT is 0. 1, T is less than or equal to P, T plus plus. F times mimv P mod. R is P minus T. Ants is equal to ants plus R times Q mod times G mod. Ants equal to ants times fact n mod. Okay, how far off are you? What in the world? This wouldn't make a difference, but what in the world? What is this then? This feels like it should work. C2. Damn. Is that correct? That's not correct, right? Is it? Wait. What's the old code? Yeah, that is correct. Okay, but you overcount here. Do you work here? No, you way overcount here. Why do you way overcount? XC2R. Well, F is 1, D is P plus Q plus 2. Let's see. I go q is not equal to x, f is f times 2 mod mod. Well, t is 1, t is less than or equal to p, t plus plus. Plus r times q mod mod times g mod mod. How big is this? $604,800. It's like more than double the answer. Product LCB. C is greater than 0. Vector PL R is V. Auto XC2R. Right. So for P is 1, P is less than or equal to L, P plus plus. For Q is 1, Q is less than or equal to X, Q plus plus. I mean, it's getting updated like exactly once, right? Yeah. P is 2, Q is 1, T is 1. Oh, wait. True, okay. Then the max of P plus Q. So T is 1, right? Then you have a factor of this. What are you? No. So C is 1, right? C2 is 7. So like pretty much the only case where this works is we don't have to choose these elements, do we? Because we don't particularly care. All we care about is the probability of this happening. So I mean here F is 1, right? Of course. So plus 1 times 1 times 1 times 1 times 7. That's 7/3. So we're saying that the max of these elements must be here, right? So we have 3 2 and then 1. Oh, wait. And then you're half a permutation. NCK L2 times C mod mod times mu2 mod mod. Okay. Now you're going to be wrong, but that's fine. Because you're actually close, right? Yeah. This is the issue, right? Yeah. Okay, good. Now this is still in Q, but this is so much better. This is so much better. This code is so much better, man. You have no idea. Okay, beautiful. Beautiful, beautiful. Because this could be sped up so much. This could be sped up so easily, man. Okay, good. Now, all we need to do now is... So, I mean, this is easy. LOR is P times P minus 1 over 2 mod mod. Right, and this is the same. Yep. Okay, so now this is n squared. Great. Now we just need to speed this up, right? We don't even need to speed it up that much. It's n squared log, which is, you know, fine. Let's make sure this works on this sample too, because we can, right? This is so much better, man. This is so much better. This is so much more promising. Like, this is so much less complicated. Because now we can sum you over all Q, right? Because, I mean, C is fixed, right? So... LL... Let's just do this. LT is... C times C2 mod mod times R mod mod. Alright, then we can get rid of this times mim2 mod mod. We can get rid of all of this. We can get rid of all of this. T. What? Why? What? C, C2, mim2. What? C, C2, mim2. T times Q times F. Why does this change the answer? What? Am I overflowing somewhere? What? 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 T is C times C2 mod mod times R mod mod times mim2 mod. Oh my god. You're an idiot, that's why. You're a freaking idiot. Okay, we're simplifying this as much as possible. Okay, good. Let's make sure you work on the 100 case. Beautiful. All right, now we have this complicated denominator. It's really not that bad. I mean, all this casework can go away. This isn't that bad. Let's copy this. All right. Yeah. So Q is not equal to X, so that's not true. Minus minus D. All right, okay, so now we just have to do this. So if Q is equal to X, which is not true, so F is F times mim D mod mod, minus minus D, if P is not equal to L, right? All this, none of this changes. Yeah. And get rid of all this casework too. For LOP is L. P is 1, P is less than L. Yeah, we can get rid of all this casework. So now P is not equal to L. So it's mim P plus Q plus 2 plus mim P plus Q plus 1 plus mim P plus Q. And then, so it's 2Q over that. So we need the sum of 2Q over that. How do we do that? 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 So we have 2q over p plus q plus 1, p plus q plus 2. So this can all be some mega polynomial in q. We can also compute the inverse of this. No, we need the sum of this. Wait, yeah. Okay, never mind. We need the sum of this efficiently. T times q mod times f. So, how does this work? How does this work? Q is 1, Q is less than x, Q plus plus. F is 1, D is P plus Q plus 2. I mean, this can be done with f of t, right? But yeah, this can be done with f of t. So that's fun. How does that work? Oh god, dude. This is so dumb. This is it. This is the solution. This is what we're down to. This n squared loop. It's not even n squared. It's like n squared over 2, which is, you know, still bad, but f is f times mim d mod minus d. F is f times 2 mod. F is f times mim d mod. Right? F is f times q mod. How do we do this? Do they want us to do? They don't want us to do FFT, right? They don't want us to do FFT, do they? Seems like they don't. But I mean, it wouldn't be that bad. You know? It wouldn't be that bad. We need the sum. Well, actually, would it be that bad? Wait. So, I mean, we need 1 over 1 times 2 times 3 plus 2 over 2 times 2 times, yeah. And then we need 1 over 2 times 3 times 4 plus 2 over 3 times 4 times 5 plus 3 over 4 times 5 times 6, etc. So how does that work? How does that work? We can pragma this. This can be pragma. This can very well be pragma. This can very well be pragma. Like we can totally, like we could absolutely pragma this. We could absolutely pragma this. Should we? Should we, man? Should we? Screw it. Let's do it. Let's pragma this. Let's pragma this out of here. SQ. For Li is 1, I let's do it N plus plus. SQI is I'm tired of this problem. Let's pragma this. We're pragmaing this. We're done. I times mimv I times mimv I plus 1 mod times mimv I plus 2 mod. LS is 0. For LQ is 1, Q is less than X, Q plus plus. S plus equals Q times SQ P plus Q. Ants is equal to ants plus 2 times S mod. Why? S is equal to S mod equals mod. S is equal to 2 times T times S mod. Yeah. Okay, we're doing this. Let's see how fast this is, right? Yeah. So I mean, this should be instant, because this isn't even a problem. Yeah. If we run 3, right, then this is the interesting part. 2 and 3 are the interesting parts. Okay, sure. Int. Right. Okay, but we're doing it twice. We are doing it twice. Okay. Yeah, we're doing it twice. Okay, so we are doing it twice. Okay, so if store P S is equal to PSP, LQ is equal to store P. While LOQ is store P. S is PSP. LOQ is store P, right? While Q is greater than or equal to X. S is S minus Q times while Q is greater than or equal to X. So this means we're doing all of this, right? While Q is greater than or equal to X. Wait. If Q is equal to X, yeah. While Q is greater than X, minus Q. While Q is greater than X, right? Now let's just be smart about this. So Q is going to represent, Q is going to be exactly the highest value that's been stored. So while Q is greater than or equal to X, yeah. While Q plus 1 is less than X. Plus Q. Okay. Else store P is equal to X minus 1. PSP is equal to this. Wait. Okay. All right. S plus equals Q times SQ P plus Q. I don't understand what this is. This is stupid. T is equal to Q plus 1. That's not any better. Oh, because it's not even right. Yeah. Should be P plus 1, whatever. Okay, I mean, this is correct, though. Seems to be like a little bit faster. Seems to be the slightest bit faster. I mean, we could do this with FFT, right? We could do this with FFT. But how? I have another one here, don't I? Wait, what? How? God damn it. Yeah, that's fine. Okay, so it's not gonna overflow. Int. Nice. How much faster? You're slower, right? You're about the same. Compiler would matter, something like that. You have to be long. Damn, we're having the same problem again, that this has to be long. Q is 1 up to x, q plus plus. I don't want to think. We can do this with FFT, but I don't want to think, man. It's just annoying. Can we do this with FFT? I'm not sure. Q is 1, Q is less than x. I mean, it's a single multiplication. How? Okay, I mean, it's 1 billion operations. Damn, man, it's so close. It's so close. It's so damn close. Can we use... If we iterate over Q instead. And then it's P choose 2, which is harder. I mean, it's P choose 2 times Q times this stuff. Can we make life easier somehow? Does this make life easier? It's P choose 2 times Q. P times P plus 1 over 2 times Q over P plus Q, etc. How does that help? It doesn't, right? It doesn't. does not. Q is 1. Q is less than x. Like, if we just go slightly lower, you're going to work. That's the thing. If we just go slightly lower, you're going to work. Yeah. And they don't want n squared to pass, obviously. They don't want n squared to pass. I mean, my God, man. This is absurdly close. S plus equals Q times SQ P plus Q. What if we like... No. Wait. Oh. Okay. I see. Okay, we can be smart about this. We can indeed be smart about this. Okay. Okay, enough pragmas. Enough pragmas. Fine, I give up. We'll do it smart. Okay. Fine. I give up. We'll do it smart. S is equal to S plus Q times S cubed mod. S is equal to S minus P times S cubed P plus Q mod plus mod. Enough pragmas. Fine. Alright. Okay. R is equal to R plus min by mod SQ I is equal to R. I wait. S is equal to SS. What are you? So you're L minus 1 plus X minus 1. L plus X minus 2 minus SS L minus 1 plus mod twice. No. What are you? L plus x minus 2. Oh, it's P. Not L. P plus x minus 1. No. P plus x minus 1. Minus SSP. Off by ones. Beautiful. Okay, now we do the other one. Which is to say, LS2 R2 is equal to R2 plus square I mod. S2I is R. LV is S2 P plus X minus 1 minus S2 P plus mod V is equal to V times P mod. Beautiful. Okay, and now we're good. What? 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 What do you mean? What in the hell? How? How? What in the hell? What changed? P choose 2 mod. C times C2 mod times R mod times mid2 mod. Well, S is 0. S is SS P plus X minus 1 minus SSP plus mod. Mod. Q is going to go up to X minus 1. So this is when you're asymmetric, right? But like, what? What do you mean? What do you mean? What do you mean, man? Come on. Come on. Oh, you're so close, dude. Oh my god, you're unbelievably close. R plus I times SQI. SSI is R. R2 is R2 plus SQI mod. S2I is R. R is P times if we add Q to make both the numerator plus, so we have Q plus P minus P, and we have P plus Q, and then that's independence. What do you mean, dude? What do you mean? Are you serious? Okay, what's the smallest case in which you fail? God, man. It's a freaking problem. 5-2, right? Okay. See out. Wait, over or under? We're over, right? Yeah, we're slightly over. Why are we slightly over? This is the wrong one. For P is 1 up to L, P plus plus. R is P choose 2 mod mod. T is C times C2 mod mod times R mod mod times mim2 mod mod. Well, S is 0. S is... So this goes up to... Q goes from 1 to X. X, X, X. Q goes from 1 to X. X minus 1. So this is SS P plus X minus 1. Did you work with the loop before? Have you been broken this whole time? Wait up. How long has this been broken for? Where are you? Are you... What in the world? Oh, this is the old program. Okay. We have if C2 is greater than 0. That's fine, right? Yeah. That doesn't really matter. How long has this been broken for? Can someone... Do you work? You work. You work. But as soon as we do this, I'm a clown. How did that pass? How, what? Somehow that magically worked. Now it's even worse. Why even worse? How are you even worse? R2 is R2 plus SQI mod mod. How are you even worse? LOV. I'm very, very confused. Q plus P, right? Okay, so let's do this. Let's do this gradually, right? You're gonna be negative? If you're negative, that's fine. That works. So it's the second thing that's broken. Very, 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 very confused. Very, very confused. So confused. So unbelievably confused. R2 is R2 plus SQI mod mod. R is P choose 2 mod mod. LT is C times C2 mod mod times R mod mod times MIM2 mod mod. S is 0. LLV, it's the same prefix sum. Right? Am I crazy? I don't. Because I'm adding it. This is a correction, not an addition. And now we're good. And now we're good. Sorry? What? Sorry? There we go. Yes. Okay, we're good. Jesus Christ, what a problem, man. What a problem. That taught me a lot. I was ready to cheese, although there was a nice way to get around that linear thing. So, good on that for cowardice. Cowardice paying off by accidentally discovering the optimization. Which, you know, cool. Cowardice paying off, man. Never thought you'd see the day, huh? So this works on the 100 cases, right? Beautiful. Okay, good. Jesus Christ. That was a problem. That was a problem. That was a problem. We did it. We did it. It's done. We did the problem. The problem is done. It's 3,200. God, math, dude. Math. So the key was to ignore the notion of individual elements and just count straight up contribution, pair contribution, linearity of expectation, and then be happy. And you get the sum, and it's not easy to optimize, but you add p to it. You add p, and then you subtract p. You have two terms that are independent, so you make them not independent in the numerator where you're allowed to do that. That's okay. That's pretty smart. That's pretty smart. That took 4 hours, but we got it. So that's cool. Yes, indeed. All right, let's do that div too. Enough combo for a week, perhaps. Here's the cowardice. So there was a div 2 this morning. I said I was gonna do it. Finally gonna do it. Although it was long. Okay. We will do this. All right. I'll be right back, and then we'll start. Hello. Okay. Here we go. Let's do this. So I've not seen standings. I know nothing about this round, which means we are set to do it. Okay, you can go. All right. Cool beans. I don't know why I keep saying that. F1 and F2. Sounds fun for me. Okay. Okay. Just Y? Alright. C and N is guaranteed the no two constraints. Okay, so VL T L is equal to -1E9, R is 2E9, 4 Li 0, I is less than N, C into X to Y. Must be greater than or equal to X. If X is equal to 1, L is max. Seven 0 90 0 0 8 yeah 8 something sure. C into N VLT L is -1E9 R is 2E9 C into X to Y so +1 yeah okay beautiful. Right, summation game. Remove at most k elements from the array. At most x. So is Alice going to remove by absolute value? How's this work? All elements are positive. Oh, okay. Well, that matters. Are I always going to remove a prefix? Suffix? I mean, suppose we do. The Bob will make the biggest. If we're going to remove this, right? If we're going to leave a gap, if we're going to remove 3 but not 5, And Bob will make this -5. Yeah, okay, so we're always going to remove the suffix, so sure. Okay, R is 0. For Li 0, I is less than or equal to y, I plus plus. R is equal to negative PS. R is greater, R is less than 0. So what are you? So you're n minus 1 minus I minus x plus 1. PS 0. Kind of an ugly set. 0, 2. Wait, what? Oh my god. You bro. Why did you give the input that way? 3. Okay. I thought it was fundamentally wrong. Jesus. C into nyx, I is 0 up to n, C into ai. Sort r is 0, I is 0 up to n, r plus equals ai, bi is r. So if L is greater than R, or R is less than 0, return 0. Yeah. So negative PS, m minus 1 minus I minus x plus 1. M minus 1 minus I. Yeah. Okay. Alright, partitioning the array. L1 has an array A1 to N. For every positive integer K that is a divisor of N. What a weird, okay, what a weird set, man. Partitioning the array. Every positive integer K such that if he replaces every element in the array with its remainder when divided by m, then all subarrays will be identical. Ugh, it's this problem again. Okay, so every positive integer k that is a divisor of n. Okay, there are no zeros. So if you're a 1, right? Oh wait, no, we can only do it once. So we need you all to have the same remainder mod m. So it's the GCD of, okay. So it's the GCD of u, right? K equals 2. Okay, sure. C into n. VLAN for LLXA C into x. For L k is 1, k is less equal to n, k plus plus. If n mod k is equal to 0. For L t is 0, t is less than k, t plus plus. For L r is t, r plus k. G abs a r minus a plus k. Okay. 2 1 2 4 4 1 2 1. Yes. C into n VLAN. K is 1 up to n if n mod k is 0. G is 0. T is 0. T is less than k. T plus plus. R is t. R plus k is less than n. R plus equals k. Yeah. Sure. Okay. Why was that easier than B? Right, array repetition. Jaden has an array A which is initially empty. There are n operations of 2 types. That was easier than B, man. That's freaking easier than B. Okay. Jaden has an array A which is initially empty. There are n operations of 2 types you must perform in the given order. Jaden appends an integer x to the end. Jaden appends x copies of array A. It's guaranteed that he has done at least one operation of the first type before this. Bro, okay, we're gonna do this, huh? We're gonna do this. We're going to do this. Jaden has an array. Okay, yes. So I'm glad they have overflow tests, at least in the samples. That's very nice of them, but still, it's kind of a dumb problem. Vector array LL3 B. LL point is 0. So for LI We can just like, okay, let's not do this. Let's do neo res q, neo qrq. Vector pl ops n, cn ops I. So if point b is equal to 2, r is point plus 1. While qp is less than qr size, and qr qp dot f res qr qp dot s is equal to x. No, we need to, okay, we need to do this anyway. Yeah, we need to do this anyway. Okay, fine. Vector array L3tr. Yeah, we need to do this anyway. Okay. Fine. LR is point plus 1, tr dot push back LRX. Vector array L4 LR1X plus point else x is equal to min x 3e18 over point plus 1. Alright, so if point is 2e18, point is 2e18 plus 1. Yeah, okay, sure. If point is much bigger, right? If point is like 3e18, this isn't gonna work. Yeah, okay. LR is point times x. tr dot push back LR2x. Do we need the second one? We don't really, right? Well, let's have it. Okay, now while 1. tr.end array. So what do you? We want x, -1, -1, -1. B is equal to 1. CMB. Do we don't space. Else. So what exactly do we want? If x is 5, right? We want point. Else x mod equals v. Yeah. Wait, we're 1 indexing. So if we have 2 times point, what do you? X is equal to God, why? Break. Okay, so PRTR. Why are these samples so like wide? These samples are so wide. So 1 1 1 1, 2 2 1 2, then we do 2 1. Point times. Oh, okay. I see. 9813136388. Okay, it works. It works, I guess. Scene to end a queue. Vector PL ops n. Allow point is 0. Scene to ops I. Vector array LO4TR. LOQP is 0. For auto BX ops, LL is point plus 1. B is 1. LR is point plus 1. TR dot pushback RL1X. If X is equal to 1, continue. Yeah, okay. B is 1, R is point plus 1, TR dot pushback RL1X plus point. Else X is min X, 218 over point, plus X. If X is 1, continue. LR is point times X. TR dot pushback RL2 point. Point times equals X. Scene to X. Lower bound. RLBV. B is 1. C on V. Else X is X minus 1. Mod V plus 1. You have 4 seconds. It's N. It's N plus Q log big log n. Yeah. This should be fine. This should be fine. Cool. Oh, you're not even close to slow. Okay, cool. All right, we're doing good. Okay. Patrick calls a substring of a binary string good if this substring contains exactly 1, 1. Why do these problems exist, by the way? I don't know. I find myself asking that question like more and more often the more I do these div 2s. Patrick calls a substring of a binary string good if this substring contains exactly 1, 1. Such that S contains exactly n good substrings and has no good substring of length strictly greater than k. And has no good substring of length strictly greater than k. Binary strings S, such that S contains exactly n good substrings and has no good substring of length strictly greater than k. So, I mean, okay, so sure. LO DP 2505 2505. Okay, so C and N to K. So if we have 0 and 0, then we're going to gain 1. If we have 0 and 0, then we're going to gain 1, and the biggest length is going to be 1. If we have 0 and 1, then we're going to gain 2. We're going to gain 2. And yes, okay. So for I is 0, 0, I 0, I is less than k, I plus plus, dp ij is 0. For L, I is 0. I is strictly less than k. I plus plus. dp 0, I is 1. For L, I is 0, I is less than n. I plus plus. For L, j is 0. J is less than k. J plus plus. For L, t is 0. T is less than k. T plus plus. L, sc is I plus j plus 1 times t plus 1. L, sl is j plus 1 plus t. If sc is greater than n, or sl is greater than or equal to k, or sl is greater than k, break. dp sc t is equal to dp sc t plus dp I j mod mod. We have 998 mod. Sure, and you're fast. You are very fast. 1, 3, 5, 12, 9, 2, 5, 9, 2, 2, 8, 0, 2, 259.280.854. Yeah, so scene to end to k for I 0 up to n, for j 0 up to n, dpi j is 0. SC is I plus j plus 1 times t plus 1. SL is j plus 1 plus t. If SC is greater than n or SL is greater than k, break. dp SCT is dp SCT plus dp ij mod mod. You're going to work. This is going to work. You're going to pass. That was easier than D. What in the world? What is this round? Wait, why does that have so many solves? Who is solving this? Okay, sure. I guess we're doing well. Sure, man. Sure, we'll take it. We'll take it. Okay, F1 and F2. Q is 5. Q is big. Okay, sure. Thomas is sailing around an island surrounded by the ocean. N rows and M columns. Rows are numbered from 1 to n, top to bottom. Columns are numbered from 1 to m, left to right. Sure. Yeah. Island, ocean, and underwater volcano. Cells representing the island are marked with a pound. Cells representing the ocean are marked with a dot. Cells representing under. Okay. Set of all island cells. Sure. It's guaranteed that there are no island cells at the edge of the grid. Path starts and ends at xy. As long as the distance starting from xy is the minimum Manhattan distance from a cell on the round trip to an underwater volcano. Okay, and M is small. Okay. Okay. That's a lot more reasonable. It's guaranteed that there's at least one island cell and at least one underwater volcano cell. It's guaranteed that the set of all island cells. Okay, round trip. Still inside the grid. Path must go around the island and fully encircle it. Some path P fully encircles the island if it is impossible to go from an island cell to a cell on the grid border by only traveling to adjacent on a side or diagonal cells. Yes. Find the maximum safety of a round trip starting from xy. It's guaranteed that xy is an ocean cell or an underwater volcano cell. Damn. You're really gonna do this, huh? You're really gonna do this. Safety or a round trip. We're really gonna do this. God damn. We're really gonna do this, huh? We are really doing this problem. Oh my god. Okay, well, I mean, sure, for each query, do a binary search, right? And then see if God damn, dude. You're really gonna do this, huh? We're really gonna do this. We're really doing this problem. We are really doing this problem. Bro, like, come on, man. Like, come on, dude. Why do we have to do this? Why do we have to do this problem? Why are they making us do this problem? Why are they making us do this problem, dude? Oh my god, this feels horrible. We have to do this problem. This is so sad. This is so sad. Reminded to press finish update on Chrome, yeah. Oh my god. Okay, so let's do the easy version first, because it'll make life easier. Why do we have to do this problem, man? Okay, so I mean... Q's up to 5. Manhattan distance, right? Q's up to 5. Why is Q 5? Why not 1? Why not make it 1? It'd be nice if you were 1, but you're not 1. Okay, so we're gonna do this. We're gonna do this problem. I guess we're gonna do this problem. This is their anti-AK, huh? This is their freaking anti-AK. And we have to do it. Vector string G. CN to GI. For Li 0, I is less than Qi plus plus. Okay, now if Gij is equal to V, dist n VLM -1. dist RC is greater than or equal to MV, continue. Valid RLC, return R is greater than or equal to 0, and R is less than N, and C is greater than or equal to 0. Constant DR4 is 0, 0, negative 1. Constant DC4 is if valid NR and C presence of ion cells does not impact this distance. If valid NR and C we can do this all from the beginning. That's true. Okay. That makes life easier, actually. For I 0 up to M, for J 0 up to M, if Gij is V, Q dot push Ij, dis dot J is 0. Dist NR and C do not have multi-tests, thank God. 6, yeah, sure, okay. LV is less than RV. MV is LV plus RV over 2. Let's just do the easy version, right? C into R to C minus minus R minus C. LV is less than RV. Okay, so bool pause is equal to 1. If dist RC is greater than so for testing for 1 and dist is 1, this is, can we form a component with everything greater than or yeah, so if dist RC is less than MB, pause is 0, else yeah, if dist RC is less than MB, pause is 0, else so we need to mark everything reachable from X, Y. well, RC, C into R to C, minus minus R minus minus C. Bool. No. Okay, ij is 0. If valid nr and c and dist nr and c is greater than or equal to mb and not okay nr and c, okay nr and c is 1, q dot push nr and c. Okay, now what we need to do then is okay, RC is 1. Well, not Q dot D. Okay. Now this is equal to, okay. If Gij is equal to valid and C. Seg fault. Do you even make it? Target 6, 4. 4, 5, 6. What is it? Yeah, sure. C into R to C, minus minus R, minus minus C. Ij is beside J is 0. make it here. R0. What? How? There are no multitests. Seed NMQ. Vector string GN. I'm so confused. Yeah, that's correct. That's correct. R0, C0. Oh, LV. That's why. Cool. Why exactly? Pause. Where are we printing this? Oh. R plus DRD, a valid NRNC and distant RNC. I can't write BFS. Can't write BFS. Cannot write BFS. That's okay. -1. Oh, because I didn't. And okay, beautiful. What? Okay, so we have some problems here. This is very problematic. PR, MB, okay. Const LKD. Wait. 11100 const LKC 8 is equal to KR. Yeah, there we go. Okay. What? Oh. One, two, three, four, five. 1, 2, 3, 4, 5, 6. No, it's 7, 7. Wait, what is going on? Oh, holy Christ. Okay. There's a lot to do in this problem. So, send nmq, vector string gn, vector vl dist, n vlm negative 1, q plq, gij is v, q dot push ij, well, q dot empty, auto rc is q dot front, q dot pop, dist nrnc is negative 1, dist nrnc is dist rc plus 1. Okay. pl targ, for I is 0 up to n, gij is hashtag, yes, targ is ij. I is 0 up to q, lrc, c into rc, mv is lv plus rv over 2, will pause as 1. Dist rc is less than mv, pause is 0 automatically. Otherwise, I is 0 up to n for j is 0 up to m, ok ij is vis ij is 0. Ok ij is vis ij is 0. Q plq, q dot push rc, ok rc is 1. So for each cell, auto rc is q dot front, q dot pop. For d is 0 up to 4, if valid nrnc and dist nrnc is greater than equal to mv, and you're not already visited, and you're not an island cell. Okay, sure. Otherwise, auto rc is targ, q dot push rc, vis rc is 1. Well, now q dot empty. Try and leave the cell. Try and leave the grid. Okay, sure. Okay. I thought this would be fun. I thought this round would be fun. My TLE. Okay, sure. Cool. Cool problem, bro. God damn. Okay, now we have to do the hard version, I guess. Damn, Jerome, good job, man. So Jangli has solved both. Nobody else has solved both. Okay. Jesus, man. All right, what is going on in this? So, I mean, now we need to like, so I mean, we can characterize the components that, you know, have you. We can characterize the components that have you. And then we need to DSU you together. And then we need to check if you contain the island. So how do we check if you contain the island? How the hell do we check if you contain the island? This feels like a knowledge problem. It feels dumb. It feels dumb. Each time going to a cell with a common side. Manhattan distance between cells R1, C1 and R2, C2. Yeah. So So okay, we can look at the anti-components. But like not even necessarily, right? Because if you contain any ion cell, you contain the whole island. So we need to fix a single ion cell, right? If you contain any ion cell, you contain the whole island. So we fix a single ion cell, then we fix a single ion cell, right? Then for each component, at some point you become good. Once a component becomes good, I mean, like, this is what we're thinking of, right? Like, we have some, like, outer ring here. Once a component becomes good, four, 10. Once a component becomes good, then we stop thinking about it, right? So once this cell moves out of danger, right? Now you can find the answer for every cell, because we're gonna have to do that anyway. Let's find the answer for every cell, right? So, I mean, this can get very, very tricky. This can get very tricky very quickly. We're looking into components. We're looking into components that contain the island cell, right? Freaking jangly, man. 17 minutes. God damn. That's crazy. We're looking into these components. We are looking into these components, and we want to I mean, a component could contain a circle that doesn't contain the island cell, right? Like we could contain a circle that doesn't contain an island cell. It's freaking valleys all over again. It's this Yusaku problem that has traumatized me to no end, and now we're here again. Now we find ourselves at the same position, except it's a div 2f 2, and it's painful. And what? What do we do with it? What do we do with it, man? What do we do with it? What do we do with you? What do we do with you, man? So as soon as a component becomes good, if we're thinking about the anti-components, right? If we're thinking about the anti-components, when does a component become good? You can have a circle without having the island. We could have a circle that doesn't have the island in it, but you'll still be a circle component. And that would be like bad. We could have a circle that still has, we could have a component that has a circle but doesn't have the island component in it. Sailing around islands surrounded by the ocean. Safety of a round trip is the minimum Manhattan distance. Find the maximum safety of a round trip starting from X, Y. A set of cells forms a single connected component, and from any cell of this set, it's possible to reach any other cell of this set by moving only through the cells of this set. Make hacks only if both versions of the problem are solved. Gaussian island can be represented by a grid with n rows and m columns. The rows are numbered from 1 to n from top to bottom. How do we keep track of good components? How do we keep track of good components? How? Because we can have this inner ring that gets enclosed faster than the outer ring. This inner ring gets enclosed faster than we're thinking about the anti-component, right? We kind of like, okay. What is the anti-component? So the anti-component is going from 0 to that and doing this. If a component completely circles the island, then let's sink it. Let's make it ocean. If a component completely circles the island, let's sink it. Now, how do we tell when a component stops being good? We can have cases like this, but like the other way around. And what do we do with that? What do we do with that, man? Determine if the connected component contains some cell. Determine if the connected component contains some cell. Right? What in the world? What in the world is going on? So we can BS on when the island is contained. We can BS on when the island is contained. E5, right? So if we BS on when the island is contained, then what will this be? What will it be? N root n log n something? That's wild. Man, this sucks. Why does this have to be the last problem? How does this work? Okay, I mean, this cannot possibly be it. No. I'm not good at Googling. I don't like it. Okay. Kind of glad to know that nobody else has solved this so far. That's sauna? No. This is really dumb, though. This is very dumb. Determine the distance at which the ion cell can reach the edge. Banner. I don't have to do this. I don't necessarily have to do this problem. Bro, nobody else has solved it. What in the hell? Geothermal is going for full. People are going for full. Neil's probably going for full. Like, bro, come on, man. Don't make me solve this problem. I don't know how to do it. It doesn't seem like it's nice. Like there is no scenario in which the solution is nice here. I mean, something explaining this specific structure. So I'm saying you have to contain a certain cell. Yeah, it's an apple. Saying we have to contain a specific cell, and that's all. One cell has to be contained. One cell has to be contained, right? I have a hunch that we can do this stupidly. For an island cell. Right. Find your minimum path out. Is it minimum or maximum? It's minimum, right? Find your minimum path out. Yeah, find your minimum path out. Find your minimum path out. Now for anything that's connected to you. Bro, I'm like, who else has solved F2? Are people solving F2? Nobody else has solved F2. Bro. Oh my god. Oh my god, man. What is this contest? This was fine until F. They just didn't have to put F on. It would have been fine. It would have been so fine. They didn't have to do this. They didn't have to do this to their contestants. They didn't have to. You could allow us to have fun, man. You could allow us to have fun. My god, dude. You could allow us to have fun. We could have fun. We could have fun doing this contest. We could enjoy ourselves. Wouldn't that be nice? Wouldn't that be so nice, man? It'd be so nice if we could freaking enjoy ourselves. I don't want to do this problem. I kind of want to mind solve it, but I don't want to, like... I mean, for the island, find your minimum path out. For the island, find your minimum path out. Then... for any cell... Right, then we find the component that blocks you. So if your minimum path out is 3, right, then find the component that blocks you. Find the component of size 3 that blocks you, and then mark it, right? And then for any, and then what? Like, and then what? What's after that? Because, like, there could be more complicated things, right? Like, we need to then mark off everything that's adjacent to that component. Mark off everything that's adjacent to that component, and then... Bro, did New and Geothermal just leave the contest? They just leave? Are they actually going for F2? Oh my god, dude. Why would you put this problem on a contest? Why would you do that? Why would you put this on a contest? I'm so sad. I'm so sad that this is a Codeforces round. Oh my god, man. It's so unfortunate. I'm just watching. Just watching, man. You know, screw it. We're not doing this problem. How many people saw this? Rainboy got it, of course. How many people actually saw this? Okay, some people did actually get it. That's kind of wild. Yeah, Jerome actually won the round. Good on him. Yeah, I'm not doing this. Screw this. This is dumb. I'll take my 9th. Fine. Alright, let's go back to real problems. So we're going back to this one. Why? Okay. So you have 10 to the 5th real queries. Set of non-negative integers. The smallest non-negative integer that is not included in this set. Yeah, so like um okay, interesting. So what we can do then is let me just see if there's some node with degree at least 3 in the induced subtree. That's what we need to do. Degree at least 3 in the induced subtree. How do we check that? How indeed do we check that? So we assume the root is at node 0, which we can do. Well, no, because it's going to reroute. Can we do like a what? I'll get rid of that. Struggling to open a water bottle live. So maximum value of max v on all possible. Di is a direct ancestor of node I in a tree. So I mean, 0 could be completely moved. That would shake things up. Okay, so for each node, if we could maintain the lowest node in your subtree for each subtree, and then the lowest node outside of it, the answer is the min over all nodes with degree 3 or more of that value. Problem is like what? How do we do that? How we do that? These like linear predicates. We can't do linear. Stop thinking about linear. All right, so optimal path is a path in node 5 to node 4. 4 set of values to 0 and 2, 3, and the max is 4. Ninth query. There are 9 queries. Okay, so I'm going to assume there's a query in between everything, because why not? That's weird. How do we measure induced subgraph? So what if we could find the path? Like find the path itself. So like pick 0. Do some binary search shenanigans. Somehow we're using swaps. I mean, it doesn't really matter that's a swap. It just maintains that it's a permutation. We're moving some elements around. And most of them are the same. That's the thing. Most of them are the same. Suppose the answer is initially like 7, right? It maintains some property, right? It maintains some property. Can we find the diameter of the induced subtree? Does that somehow help? Does that somehow help? Does it somehow help? What does it do, man? What does it do? What does it do? Okay, let's think of some square root BS, right? There's always going to be some square root BS. Maximum value of max. I don't even know how to check pathness. How do we check pathness? How do we check pathness? So for pathness, I'm going to check that for all nodes, you're big. Number of nodes of a tree. Permutation P. It's guaranteed that all numbers are different. I like LCA stuff. That's what we need to do, right? So either you're contained on the path, then or you extend the path, right? How does this work? Either you're contained on the path or you extend the path. The root in node 1. This tree is not just a tree. Permutation P of integers from 0 to n minus 1 is written in nodes, and number pi is written in node I. Let's define a function max s, where s is a set of non-negative integers. For some node, the answer can change a lot. some node of degree 3 that has you. For a node here, there will be some node of degree 3 that has you. P of inverse from 0 to minus 1. Where pi is written in node I. There will be exactly one node of degree 3. So the answer is the sum min, or you the third min. Get crazy here. So here's some path. A wacky idea. I have a very wacky idea. This is, wait up. This is crazy. Okay, wait. 3 seconds. Yeah. So holy crap. Okay, so this can't be it. This cannot be it, man. What in the world? This cannot be it. This is insane. This is, oh my god. This might be it. This might be it. This might actually be it. How do we check this? We build a segment tree. So that a node in the segment tree represents the, holy Christ, and this works, and this will work, and this will work. I guess it'll work. I mean, like, why not, right? Why not, right? I guess it'll work. Okay, so we need to do some case work. Wait, actually, how do we merge? Wait, this may not work. Wait, no, yeah, wait. No, wait. Ah, damn. Well, this might not work, because once you form a path, right? This doesn't work, does it? No. Wait. Something like... If we do this, right? Then you do this, and then you don't work. How do we find the thing that does work, then? If you don't work, how do we find the thing that does work? Well, yeah, we can. The problem is it's binary search inside the merging. There are log merges. Binary search takes log. Like, we know this works. So we just need the path. How do you tell if two paths form a better path quickly? How do you tell if two paths, when unioned, form a bigger path? That's a lot of LCA calls. Okay, that's stupid. Let's not do this. Let's do something less dumb, perhaps. Something less dumb. Some less dumb. How do we do something less dumb? How does something less dumb work? Why is it rooted? Oh, for the sake of input. Oh, well, this would actually work. I don't really want to code this, though. What difficulty are you? 29. If you both go up, then you need to either be a child of you or in a different subtree as the taller one. Okay, we'll call it solved, I guess. It's redef. Case fixed. What does that mean? Case fixed. We have 1, 2, 3. Two to the 14th. That's That's like small. Let's do 2 to the 14th. So, what's happening here? So A1 will be XORed with A1. A2 will be XORed with A1 XOR A2. So A1 will be A1. A2 will be A1 XOR A2. Then A3 will be thus A2 XOR A3. So A1 will influence A2 and AK plus 1. where it will then influence so A1 will influence A2. A1 will influence A1, and then A2. And then AK plus 1, right? Because like A1, right? We're going to XOR it. Then we're going to XOR it with A2. We're going to XOR it with A2. We're going to XOR it with A2. So then A1 will be on A2 to AK plus 1. A2 to AK. Then we're going to XOR with A2. So you're going to be on AK plus 1 only. And we get it in AK plus 1. You're going to influence A2. Then you're going to influence, and if A2 is doable, you're going to influence AK plus 1. If you're not doable, like if you're the final position, yeah, this is fun. This is fun. So when we change a number, thus, we're actually changing a range of numbers. When we change a number, we're actually changing a range of numbers. And if you happen to be oh, but that's annoying. And if you happen to be the last one, yeah. Okay, well we can handle the last one specially, I guess. Why not handle it specially, right? So if you're here, right, you're gonna influence this and this. Is that it? And then we just check the end and see that you're all zeros. And we just check the end and we see that you're all zeros. So like suppose n is 9, k is 3. Then position 5 is going to update position 6 and position 8. That's not going to update position 9. Position 4 is going to update position 5 and position 7. Yeah. So we just position 3 is going to update position 4 and position 6. Which will then update position yes. Which will then update position 7. Problem is it's XOR. How do we count zeros? Problem is it's XOR. So we handle the last element especially. So k's big. We can just do u. So that works for the end. Works for the end in O1. How do we do the not end? K is big, we don't have to worry about it. K is small. K is like, what? Like 2. Then we update all elements. We update all the elements. do we count zeros? So there's some operations. There's some operations. XOR some suffix with X, and then XOR some suffix with X and count zeros. That is how that works. How does that work? XOR some suffix with X and count zeros. We can do in reverse prefix, sure. So we do U, then we do U. XOR That's two arrays A and B consisting of n numbers. You found them, so you're 32, right? 32 or 33 in that range. We need XOR stuff. XOR stuff. XOR stuff. Yeah, 32, sure. Okay, son. Did you get a solve? Good. operation can be applied for both arrays. What's the point of the two arrays thing? Just be upfront, man. God. What's the point of the double array? Doesn't do anything. XOR suffix count zeros. Yeah, the VC wasn't bad, I guess. How do we end up doing? We got like 9 turn. Yes. What a cool problem, dude. What a freaking cool problem. I don't know what to say about it. So Neo and Geothermal both tried full, and they didn't get it. That's rough. I didn't realize F2 was the same points as F1. That's kind of crazy. That means like... Yeah, that means a lot. Good job, Jerome. Nice. And we almost beat someone who got both, but we didn't. Who wasn't Rainbow, of course. What a problem, man. Okay. Yes. Choose a summary with length K. Yeah, we can do some square root stuff. Yeah, we can do some square root stuff, right? Yeah, we can. Okay, yeah. Yeah, we can do this with square root. Alright, fine. Okay, sure. So XOR prefix with... Yeah. But like, God, okay, okay. So we can do some tomfoolery. I guess we're doing this problem. Sure, we'll do this problem. Why not? Freaking tomfoolery. C is insane, by the way. My idea for C, that problem where you have to freaking you have to maintain a segment tree where the answer for a node is the path, the maximal path of a prefix of the freaking whatever, and then you have to do path intersection, and you have to store a crap ton of info. It's kind of crazy. I don't like it. It's not worth implementing for a 2900. There's definitely a better solution than that, but it's log squared. It's whatever. Okay, I guess we are doing this. Okay, so const LB is equal to 500. We just need to not, const s is to the 14 struct data okay, so next are 2 bit sets, but we can't no, it doesn't make any sense. Okay, so C and N. Okay, so it's annoying because we have to do 2 separate things for everything. And we special case k equals 1, right? That's fun. I'll be right back. Okay, so like probably the nicest way to handle this would be to struct struct VLR vector data blocks. Okay, so now so if k is equal to 1, if k is 411, 250,411, right? Yeah. So if k is small, yeah. So if k is 1, this is dumb. Okay. Vector PLQR. For LV x, v is equal to RNG mod 2, x is equal to RNG mod s. If run car c, c into c to x, v is equal to qr dot pushback vx. Let's do this. AVI 0. AV1. Let's make this nicer. I don't, what is the point of this? Okay, if local voucher is equal to dumb qr. SPV. C functions actually makes sense. Seg fault. Are you? Okay, why did you seg fault there? Did you not? Okay, -1, 1. Sure. Okay, this works. Oh, vector. How? Okay. Sure. Okay, otherwise if k is small, so sig start. Yeah, okay. Have there's no reason to strictly rebuild. You just need to. I might as well.
D dot have rj is 1. If p mod k is equal to k minus 1, p mod k so p mod k is k minus 1, right? Then we're going to update the entire thing. P mod k is 0. St dot upt 0. K minus 1 v. Should you be a bit set? No, you should be array ls have d dot have if P mod K is 0, right? So if we're at 0, we're just going to update 0. If we're at this, we're going to update this, and then this, and then this, and then this. Yeah. st.upt 0, 0v. P is greater than 0. st.upt k minus 1, k minus 1v. Else, if we have 2, for example, right? We're going to update 1. If we have 7, we're going to update 6, and then 2. Yeah. Okay, so that's half of the casework. Sure, that's like all the casework. Okay. TV p mod k dot upt 0 p over k minus 1 v. Yeah. Yeah. Okay. Cool. Okay. So L is less than equal to LV, and RV is less than equal to R. Else if L is less than or equal to LV and LV is less than or equal to R. Otherwise, if R is strictly less than LV or RV is strictly less than L, we'll continue. Else, minus BL B dot have RJ. RJ XOR equals V. BL B dot XV XOR equals V. And it's BLB. have blb.xv. If r ants plus equals rj xor blb.xv is equal to 0. Jesus Christ. All right, now for LOI is 0, I is less than n, upt I ci. st.count k minus 1. Turn st.count k minus 1 plus c big. Res.push back answer. Okay, this is like most of the work, right? LOD is equal to C XOR AVVP is X. LD is CP. Yeah. So upt PD. Okay. All right. How stupid is this? Right. What are the odds that you're actually valid? Okay. So 5. Wait, what? Wait. Wait, what? Well, no, okay, we don't need this many queries. Why do you not compile? Thank you. 22222. Jurors -1. Yeah, so you're gonna cancel and you're gonna cancel. TVI.R. Why are you -3? Oh, wait. That's why. Okay, so that's something. -1, 1. Oh, is that why? Okay, so you're just counting wrong now. CVig. Nice minus BOB, I have RJ. J is LB, J is less than or equal to RB, J plus plus. What in the world? So you're going to influence both of these. This is so hard to keep track of. Wait, oh. That's why. Okay. Okay, so we can get rid of all this dumb printing. Okay. What? If Why are you off by 5,000? I mean, it's promising. It's just, oh. Well, that's a problem. That's not the only problem. Why are you off by 4,500? RJ XOR BOB.XV is equal to 0. What in the world is going on? So there are 2 blocks. C big is enormously negative. Why? Okay, this is a freaking eyesore. This isn't gonna change anything, but it's aesthetically better. Yeah, so C big is massively negative. TV p mod k to update 0 p over k minus 1 v. How are you going under, though? How are you going under, man? C big is 4998. L is greater than R, return 0. L answers 0. Is this why? No. Is it this? No. L is less than or equal to LV, and RV is less than or equal to R. So, like, ants is sometimes bigger than... What in the world is going on? Are you here? Is this where the bug is? Stop. Yeah. Oh my god. Oh my god. Oh, that's so dumb. That's so dumb, man. Okay. Well, that's stupid. Alright. All that tracing. Okay, well, now this code is pretty much the same. 4 Li is P. C. big minus equals AR I is equal to 0. AR I XOR equals V. And this code is pretty much the same. I'll answer. Opt ICI. Okay. Can you not? What? Oh, you're just slow. Okay, well, we're gonna trust it. Because I don't really want to generate tests. Let's just, okay, right. Pi is greater than K, I minus equals K. C big minus equals R at 0. Yeah. Pretty much same code. Okay, so 0. How big are you? So 200,000, 200,000. K is 2. Sure. 200,000, right? Let's just test a bunch of things. Test 300, 600. Beautiful. Okay. Let's set run equals 1 and run you on the samples. What? What do you mean? What do you mean? What do you mean? 0, 0, 0, 1, 0, 1. What do you mean? Come on, dude. Is it because you're... Is it because you're empty? Are you gonna cry because we're empty? Why are we crying? I is 0, I is less than K, I plus plus. P is 2, V is 2. 0 P over K minus 1 P. L is 0, R is negative 1, N is 0, V is 2. N is R dot size. Dat D. Oh, is that why? That's why. Okay, that's a good thing to check, actually. Yeah. That would have been a dumb wrong answer. We need to test this again then. 2 to the 14. Suddenly this becomes a lot more daunting, huh? Wait, why use this now? Whatever. Why are you so slow, actually? Okay, let's make the block size bigger. Okay, sure. Alright, I have faith. Cool. What's the timeline for you? 2 seconds. Damn. Convex Hall trick, huh? Cool. Alright, that was fun. Very fun problem. Very, not tedious in the slightest. Not annoying. Not, painful. No, sir. We only have fun on this stream. We only have fun. It wasn't that bad, actually. Like the more you think about it, the cleaner the code becomes. And it's just, eventually, it's just some square root stuff. It's not bad. It's not bad. Surprising that it was correct. It was pretty much correct first try. That's pretty cool. That is pretty cool. That is indeed pretty cool. Hi, Sophie. I probably missed you by now, but yeah. Nice. Okay, what do I do now?
kind of don't want to do another hard problem because, I don't know, we just did one. That took a while. It was long and slow and implementing. So what happened here? Actually, why were my tests worse? Did they not have k equals 2? And they should have had k equals 2. 200,000, 300, 200,000, 200,001. Yeah, that's fine. Should be 2, that's the worst case, right? Where is the worst case? Why do you have small tests like that? Okay. What? Okay, come on. 2667. Do they not have... Wait. Do they really not? They don't have a k equals 2 test. Damn. Okay. Okay. Cool, man. Cool, I guess. Cool. Do they have 200,010. Yeah, so you can't get away with just naive updating. But why do they not have k equals 2? That's like... Okay, actually k equals 3 would make sense, right? Because k equals 2 actually updates the whole thing. No. 4, 5, 6. They have 1, they have 10, they have 100, but they don't have 2. Interesting. Interesting. Oh well, works. Do they have strong large K tests? Yeah, they do, right? Yeah, they do. Okay. Yeah, they do. They should. They should definitely have strong large K tests. So this was the worst case, 200,000 and 100. I guess that's fine. Whatever. Cool. Square root decomp. Square root decomposition. Okay. Well, that settles it for this day one. And we solved F. We're not going to do D because D is 3,500. Mine solved C in a really scuffed way that I would never want to code in my life. So that's cool. I guess I'll just leave that be. I don't know. I don't know what to do with that. It's like... This is a strange solution. Oh well. Okay. I will do some div2. How hard are you? I'm sure we can look at this. Given a tree consisting of n nodes, every node U has a weight AU. It's guaranteed that there's only one node with minimum weight in the tree. Every node U must have a neighbor V. For every node U, deg U times AU is added to W. For every edge, log 2 times min. Huh? Huh?
every node must have exactly one parent. If I'm adjacent to two nodes with smaller weight, right? If I'm adjacent to two nodes with smaller weight, both of those must have a path to the smallest vertex. Yeah, okay, so given a tree consisting of n nodes, every node u has a weight AU. It's guaranteed that there is only one node with minimum weight in the tree. For every node u must have a neighbor v such that AV is greater than AU. Should construct a tree to minimize the weight W, calculated as follows. So for every edge, we add that formula times AU plus AV. So basically for every node that's not the minimum weight, we need to choose a node out of those with smaller weight such that you work. And somehow we do this dist thing. That is a weird weight formula. Why is this weight formula so weird? Why do I not have service? Okay, that's cool. I still have Wi-Fi, I guess, but I can't read chat now. Well, I can look at it, but... Cool. We know u, dag u times AU is added to W. Yeah, so I mean, like... Okay, so once we get past all the fluff, because there seems to be a lot of fluff in old problems, for each node, we need to pick a node with smaller weight to minimize that formula. So for every node, log 2 dist UV, right? So we can group nodes by their log. So 3 to 4 are going to be the same. 5 to 8 are going to be the same, etc. Then we note that, yeah. do this log thing. How do we do this log thing? This log thing is weird. Let's guarantee that there's only one node with minimum weight. We can do we can reroute to some extent, right? 4. Right. We're allowed to look further. Guarantee that there's one node with minimum weight in the tree. Sure. We don't really need minimum weight. We only need smallest weight, so we can do all the updates at once. And what we need to do is get the smallest weight, right? Just like consider having the answer be the smallest weight. How does this work? We need the smallest weight. For each node, we get farther and farther. And then you start becoming 7. You start becoming, like if we go down to 7, then 1 becomes 8. If we go down to 8, 1 becomes 9. Go down to 15. Yeah. Each node U has a weight A. Node U, del U times A is a W. Log 2 dist UV times min AU AV is added to W. Right. So we look at this. Oh, yeah, okay. and we just, okay, how about we get shorter and shorter, right? So we go from 8, and then we go to 7, right? And then once we get to 7, then the 1, the node at distance 1, starts contributing to 7. Starts contributing to 8 as well. Before it only contributed to 9. Now it contributes to 8. Since we're looking for less than or equal, yeah, okay. Okay, so we can do this with centroid and log squared. Sure, I'll call it that. How hard are you? 2800. Huh. How many solved? Did you actually only get one solved though? Or did you get more? Okay, you got solved by a virtual guy. Solved by this guy. Not solved by my future teammate. Oh, and then a bunch of solve. Okay. That makes more sense. So a lot of other solves, other places. Yeah. Is that an FST? Bro. Okay. Cool. Yeah, we can do a centroid. That's fine. Apparently I've solved from this round. Sure. Okay. Alright. That's cool. That's enough for tonight, I guess. Okay, yeah. Bye.